Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by Fidectis. Go to www.fidectis.com for more information.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and with me, as always, is co-host Johan Oberg. Johan, what's going on?
Hey, Chris. I'm doing great. Another great week. However, slightly jealous on your travelings, and especially being in one of my favorite cities. So I'm a little bit jealous on you.
I am in New York City, and, I was out last night. I happened to have to walk through Midtown, and, it really does not seem like the energy-saving capital of the world when you see how lit up the streets of New York are. So it's a very bright place at night. So I'm not sure how they're doing here on their energy saving, but I'm hoping they're on the right track.
Well, hopefully it's renewable, and they have started doing the transition that we spoke about so many times. I remember last time I was there, at least you start seeing more and more electrical cars, which is, I guess it's a one step in the right directions. And we had some discussions around the charging infrastructure in previous shows.
Yeah, I spent time with Con Edison, and they're planning for EV fleets and things that they've been doing. It's been pretty interesting, some of the work. And I think we'll actually be covering that in some upcoming episodes. I think there's an episode that's going to talk about some of the planning for New York and Massachusetts and a few of the Northeast states. So it'll be interesting when we get there. But what's really interesting, kind of along those lines, is we're in North America. We're talking to North American guests. And we talk about the energy transition, and we talk about moving to distributed energy, but I think that it's not that simple, right? If we remember how we had these old centralized big generation plants, we start distributing and we start looking at how we can do things like demand response and things like that, the problem becomes more complex. And I'm hoping that through today's interview, we get a better feel for what energy companies are doing to deal with this and do this at scale. That's what I'm hoping we do here in the next little bit.
Yeah, I agree. And I think scale is probably the right word as well, because one of the challenges is that we used to build everything around the one big production sites and the distribution parts. And now millions of smaller devices is actually the system built for this. This is what I'm really interested to hear a little bit more about. But also maybe a little bit, what are those resources? What we have today, but are they changing tomorrow? Are we seeing new ones? Are we seeing better ones? Only a few years ago we would probably never talk about batteries in the way we do now, but that's being a big part of it. So I think that's really interesting. And coming back to that one as well, I think this whole concept of BYOD is quite interesting. When I lived in the US, it was a different meaning if you changed one of those letters at the end, but we'll see what it is. I'm looking forward to it.
I am too. And it's interesting. Both of us come from technology backgrounds. And in energy today, I think so much of energy is about the technology. Because in order to do what we need to do in the energy transition, it's the technology that's enabling this. It's not necessarily, it's having the software to manage that. So why don't we introduce our guest and go into the conversation and see what he has to say, because he's done this already at scale with a lot of companies in North America. So without further ado, I'd like to introduce Seth Frader-Thompson, president of EnergyHub. Seth, welcome to the program.
Thank you. And I do want to say that on your point about, all those lights lighting up Times Square in Midtown, at the very least, we used to have this thing where if you were walking down the street in the summer, you'd walk by a big department store and they would have their AC blasting and the front doors wide open. And so people would sort of, you'd be sweating your way down the street and then you'd kind of veer inside. They finally made that illegal. So we've made some progress.
They have made progress, because I remember not the air conditioning. I remember having to ask for water in New York City. That was their environmental concern when water shortages were always going. If you were at a table, they didn't just give you water because you had to ask for it. That was my New York experience when I was younger.
Yeah.
Well, welcome to the show. As Johan and I say almost every guest, is we have a really good idea who you are. We invited you to speak on the show because we know who you are, but our audience probably doesn't know that yet. So maybe we should start by having you introduce yourself professionally to our audience.
Sure. Yeah. So So my name is Seth, as you said. I run a company called EnergyHub. I've had kind of a winding career, probably starting around maybe when I was 5 years old and got my first Legos, and sort of one thing led to another, became a mechanical engineer. I did my master's in MEMS, microelectromechanical systems, where you're building kind of tiny systems at the chip scale using semiconductor fabrication techniques. And I think I spent enough time in grad school in like a full bunny suit dealing with harsh chemicals that I decided I didn't want that to be my career. So pivoted a bit to robotics and aerospace. Got to do some cool stuff working on kind of early stage designs and research for some NASA stuff. And I think that kind of piqued my interest in how do you have software interact with the physical world so that the physical world can be more intelligent. But I had a bit of a hankering for something that would have a broader mass scale impact. And somewhere around 2007, as climate change started to kind of enter the zeitgeist, I started to say, how can I do both of those things? And so ultimately led to starting EnergyHub with the idea that maybe we can have the sort of energy efficiency or sort of intelligent energy use be the first killer app for the smart home. And I think that maybe broadly speaking, we were right about that as kind of a thesis, but we had not quite the right market focus or product focus. And so it took us 5 years or so from the beginning of the company until when we sort of found our groove and then turned it into what it is today.
And this, you're saying the beginning is 2009, if I recall. Is that what you consider the beginning, or is it somewhere around then?
I mean, it was my second bedroom at the end of 2007. It was 4 people through 2008. And then, yeah, we raised our first VC round in 2009.
Got it. And so, you talked about all these devices and things like that, and you had this vision. Now, for many, that vision started, let's say, like with a Nest thermostat or something like that. How does that parallel to what you're doing, or does it not?
It's a direct line. So, the concept of demand response has been around for, say, 20 years in various commercialized forms. But if you looked back 10 years and definitely 20 years ago, everyone would say, you got to do this at the commercial industrial sites because you can just go talk to one person at that site and you can enable the site and then they can become a form of flexible demand. Everyone said basically residential is too hard. But then as companies like Nest and Ecobee and Honeywell came out with connected products, you started to have this sort of latent asset that was getting built up where people were putting smart thermostats in their houses and they were just there if only you could tap into them. And so that's where this kind of bring your own device thing came about. So we started experimenting with bring your own thermostat in 2012, 2013. And it was very rocky start, like no scale at first, but over time we sort of honed all the pieces of the playbook until we were able to get a lot of scale. And ultimately, demand response is pretty simple. You say, okay, there's an extreme weather event, or you have extremely high power prices, or you have some moment of kind of acute stress on the grid. And we provide a utility with the equivalent of sort of a big red button that says, give me all you got in that emergency scenario. And so that emergency scenario is great for dealing with a true system-wide emergency, but it is not it's a hammer, it's not a scalpel, right? So over the last 10 years, we've been adding a lot of capabilities so that utility can now go much more localized. They can say, all right, we're just worried about this part of our city or this part of the grid. They can say, I need a particular load shape, not just like an everything you can give me. And that starts to point the direction in terms of, toward a much more sophisticated form of demand flexibility.
Cool. So, Seth, if we go back to the early beginnings of starting the company, you talked about the consumer part, and you mentioned also the utility part. Has that been a natural transformation towards utilities as customers, or are these kind of interlinked? So it's actually a natural one. You still work in both areas.
Yeah, we do still work in both areas, but the path was definitely not linear. So we originally launched the company with the notion of being B2C. We were going to build a sort of focused smart home system that was going to help customers understand sort of how much energy they're using and where they're using it. And so, I mean, listeners on the podcast are not going to see this prop I'm holding in my hand, but we built this little gizmo called the home base. And this thing was like a little sort of network gateway that provided the ability to talk to a bunch of different things in the house. It could talk to a smart thermostat, to a smart plug or power strip. It could talk to your utility provided smart meter. And the idea was, and we were thinking about this in a sort of largely pre-smartphone era, that you would have this thing sitting on your kitchen table and it would be the thing that kind of controlled your energy use. And over time we realized that was really not going to be a huge market, but it did kind of point us in the direction of how utilities could be part of the solution. And so this was happening in the context of the sort of post-financial crisis financial stimulus under Obama, where utilities were getting big subsidies to put in smart metering systems. And so through that phase, we sort of, I think, kind of cast the mold of a company that fundamentally understands how customers think about energy use and how to make that simple. And then also what the grid needs. And so over time, we were able to kind of turn that DNA into what the company does today. And so now our role is our customer is the utility. We sell an enterprise software platform to the utility, but we partner with the companies that make distributed energy resources, DERs, and we help both of those companies kind of bring their customers into the fold, because customers are so important to the solution here in providing all that flexible demand.
So what kind of, that's interesting. So utilities, I think we are pretty clear on. We on the Energy podcast, we both kind of, I come from the utility world. I worked with them for a fair bit. But if you look at the device manufacturers, we're talking about thousands and thousands. Is there an API, a natural API? How does that work? Because it's scale. You're talking about a number of devices. You're talking about X amount of input. So how do you enable all this?
Yeah, I mean, unfortunately, the industry has never aligned effectively around particular standards, and so there's a lot of brain damage, I think, for anyone in the space of sort of dealing with lots of competing APIs. But the short answer to your question is still yes. Any company that has a good digital strategy around their DERs has some API, and then EnergyHub has its own set of APIs and kind of a test and certification program. And at the end of the day, that's focused on a handful of things, making sure we get the data we need from devices so that utilities have kind of at an aggregate have situational awareness of what's going on with DERs. And in particular, when you bundle, hundreds of thousands or millions of DERs into a virtual power plant, giving you some sort of telemetry for that VPP. You need control. So you need the ability to command a VPP to a certain power level or to send commands to individual devices. And then you need a bunch of tools around communicating with users. And the user piece, I think, in many ways is kind of what has been unique about the residential space. It's a mass market space, right? So unless you make the incentive appealing to the end user, unless you make the pitch to the end user of like why you should do this to help your community, and unless you make the logistics really easy, there will be too much friction and people just won't sign up. And so you kind of have to get all of those things right. You have to get the user experience and all the technical details right, or else you can't scale this thing to millions of customers.
So is the user experience, so the utility selling the thought to the user, you're not, right? You're enabling this. Is that the correct statement? Your technology enables it?
We enable it, but ideally the customer is hearing the same thing from multiple places, right? So they might get an email from their utility that says, hey, we've got this new program where if you don't already have a smart thermostat or an electric vehicle, here's an incentive for getting one, and here's an incentive for kind of lending it to the grid. And then at the same time, the manufacturers of the devices are kind of promoting the same program. And so a big part of what we do is sort of running the marketing behind all of that to make sure that it's consistent.
So like an analogy might be the Energy Star program that used to take place in the US. If you bought appliances where you get some bonus from your power utility company, and then also there was some sort of value for buying an Energy Star kind of appliance. Is a similar type program?
It's similar, but I'd say it's more engaging. I think at some level, those like little yellow stickers that show up on the fridge, like people kind of tune that out. I think a better example would be, two touch points, right? Let's just say you're at the point of purchase, or maybe you already have a Nest thermostat, or you already have an electric vehicle. You want something popping up in the native digital experience, something that's in the app for that device that says, hey, we've partnered with your local utility. Why don't you sign up for this thing? Here's what's in it for you, and here's how you can help. That's kind of one piece. And the other is point of purchase. So utility marketplaces will often, and this is a whole thing we probably don't have time to go into, but utilities in the US have started running these kind of white label marketplaces where you can go buy a DER from the utility. And the reality is nobody wakes up saying like, I'm going to go shopping at my utility today. But when utilities do this well, they're running a marketing campaign to their customers saying you can get a free smart thermostat, or you can get a free level 2 electric vehicle charger. And that takes you to this marketplace the utility runs. And if you sign up to be part of a flexible demand program at the time, the utility will essentially pre-rebate the program, which enables the price to be way lower, maybe zero, way lower than it would be otherwise. And that just drives the adoption of these things, that much faster.
You said something in your answer that kind of threw a flag on the plate for me, which was, it's good for the community. I don't know that consumers really, generally, if you talk to people holistically, they'll say these things, but right, you go into the house that's still at 80 degrees, or they're not really thinking about what's good for the community because they're dropping a bucket full of water, right? And they're like, well, my thermostat's not going to make a difference. So is the consumer side of the equation ready for this, and what kind of impact will they feel? So yes, they might save some X dollars a month or get some free cool tech. But are they willing to make these sacrifices to move to this virtual distributed world yet?
Yeah, so I think that is a hugely important question, and the short answer is yes. You'd be surprised at how interested customers are, right? So, first of all, 10 years ago, were that many people paying attention? No. But if you're a customer in Texas in the last few years, you remember what happened in February, where the lights were off for many people for days. If you're in the Southwest, you're seeing forest fires all the time. So we see this constantly. People are saying like, what can I do to participate? And in particular, we try to think of these programs as not like, why should you sign up for this? But ideally, the offer that you put in front of the customer is kind of like a why not, right? Like, does this really cost me anything to sign up? Like occasionally my thermostat's going to change by a few degrees. Or in the case of a car, you come home, you're plugging the car like you normally do, and all that happens is the car might charge a few hours later than it would have otherwise. Like that costs you nothing. It's still ready for you in the morning.
So coming from marketing and communication, I think this is quite interesting because you also have one thing of selling it to the energy company, utilities, that has obviously a deep knowledge around the whole system, how it works, reasoning, and obviously their business case. Moving that into a consumer communication, slightly different. Yeah, I remember back in the days in Stockholm when the smartphone came around, all the utilities had what you talked about in the beginning, some kind of a quick look at your energy consumption. Nobody cared.
Exactly.
Now they do, because now energy prices are extremely high. So now suddenly that has changed. But so it's a little bit, but I think from coming also from the telco background, how much educational do you need to be? I understand if you have an EV, you can get a rebate on your charger, or you can get a cheaper energy. Okay, that speaks to my wallet. That speaks to my directly. But otherwise, isn't it, how hard is it to explain the bigger values to an end consumer that spends about 10 seconds a day on thinking of something like this?
Yeah. The reality is if you have to explain it, you've already lost, right? Like they're not going to sit there and like listen to an explanation or read a long document. It needs to be so simple. But this is where this partnership between the DER manufacturer and the utility is so powerful, because they're both saying the same thing, right? They're both saying like, all you have to do is sign up for this, and we'll make occasional adjustments to your device, and that's going to help keep the lights on. And people have heard enough in the background about how peak demand is an issue. You look at how some companies like, Nest, Google Nest advertises their program under the marketing term rush hour rewards, right? It's sort of intuitive what this is. And so I can talk all about this, sort of theoretically, and it may or may not convince anyone, but the reality is like the scale is there. We EnergyHub are coming up on 1 million DERs participating in utility and wholesale power market programs just in the US alone. We still have a very long way to go, but the fact that we're that far, and that should be all the proof you need that customers are engaged.
And then I guess at 1 million, what kind? You said you're more of a fine tuning. You can do things kind of gradually, or you could do it based in a region or whatever. What kind of impact can you make for the utility? So let's stop talking the consumer side. Let's look at the utility side a bit. How is this impacting their business?
Well, let's look big picture. So the Biden administration has set out a goal of decarbonizing the energy sector by 2035. So if you assume that all our fossil fuel kind of ramps down to nothing over 2035, you leave nuclear and hydro kind of roughly where they are, you're going to need about 1.5 terawatts of renewable generation to achieve that goal. The reality, though, is renewables are intermittent, and at some level, they make operation of the grid more complex, right? So the old model was you'd get a forecast of your demand for the next few hours or days or weeks, and you'd kind of schedule your power generation to match that demand. This flips that on its head. Now you have to look at what's the weather going to give me in terms of power from my renewables, and now you need to schedule demand to match that generation. So for 1.5 terawatts, our sort of 2022 analysis of like the literature that's out there and a bunch of research says that you need probably at least 500 gigawatts of flexibility to support all of that. And it's not going to be easy to get there, but it's not rocket science. Like, it's pretty clear that this is just, we are in the scale up phase of this. So we got to where we are, EnergyHub, of that 500 gigawatts we're going to need, EnergyHub's got about 1.3 gigawatts of dispatchable flexibility today. So we have a long way to go, but for the most part, we don't have to invent things that are new. We have massive tailwinds, right? Like the electric vehicle adoption is happening with or without these challenges. Smart thermostats, solar, batteries, all of these things are happening. The challenge is just how do you make sure all of that demand and all of that flexibility gets turned into something that's an asset for the grid.
So how much of this, I wouldn't say reliant, but how much of this is then driven or supported by electric vehicles? Because we only a few years ago, that was not really, still debating, is it going to take off or not take off? I started working with Tesla in 2013. And it was still very, very early. And we're talking 9 years ago alone. So now, obviously, we know it has gone over the kind of the threshold when it's EVs all the way in many, many countries, especially the Scandinavian countries where I come from. But how much of that, in terms of, from your point of view, we have 1 million today, but how much of that is kind of reliant on EVs and then the rest? Is that still the big bulk, or is it because capacity is there?
Yeah, I mean, I'm always tempted to sort of put a little bit too fine of a number on things, but I'm sure that EVs are at least a quarter of the solution and maybe half of the solution, right? They're just going to be so big. I think in the US alone, we'll have 30 plus million EVs by 2035. EVs in a way are kind of the perfect flexible resource, right? Based on the way most people charge, you're plugged in for, 12 to 14 hours overnight, but you only need a couple hours of charge. And so you have tons of flexibility just in when you charge the vehicle. So that's sort of V1G. And then you look at a typical EV being sold today, it's, probably 75 kilowatt hours typically in the battery. You're building up this incredible base of energy storage that one day we will start using as vehicle to grid or vehicle to home or vehicle to business. And between V1G and V2G, I just think you have an enormous opportunity.
All right, so you talk about the EVs going in there. The one thing I've always heard or hear quite a bit is the U.S. grid in particular is very fragile. and it needs a little bit of help. So, we're overlaying technology. You talk about smart meters at the edge, right? You got smart meter capabilities going in. How much of the grid infrastructure can we leverage that's in place, and how much of this is going to be new infrastructure that's required, or is it just kind of keeping the fragile grid, as people tell me, up and running into the future to do what we want to do?
I actually think that the fragile grid is it's probably not a fair characterization. I mean, there certainly are areas. You look at, Texas's failure to winterize power plants. Like that's clearly that was not a great source of resilience or reliability. But the thing that the U.S. market has that lots of other markets like Northern Europe don't have is we have so much air conditioning. Our whole system is built around air conditioning that you have tons of slack built into the system. So as long as you're not charging your car on the peak, so if you go to the Southwest, that peak is probably somewhere between 4 and 9 p.m. on a hot summer afternoon. As long as you're not charging on the peak, there's tons of capacity on the grid to deliver the power you need. It does kind of open up sort of a second order problem of, well, okay, you can't run a marketing campaign that says, everybody please start charging your cars at midnight, because now all of a sudden you've grown a new huge peak at midnight where everyone's car starts charging. So that kind of goes to, all right, well, so when should you charge these things? And the answer is you should do it at whatever the cheapest time is or whatever the greenest time is. So you imagine here on the East Coast, if you've got a big offshore wind farm, let the cars charge as the wind production picks up and let them follow a signal around carbon intensity or market prices or something else. The distribution transmission capacity is largely there. Oh, by the way, I mean, I should say, like, for anyone who's worried about, are people really going to be willing to do this? Like, your iPhone is doing this today. Most people have not really noticed that when you plug in your phone on your nightstand, your phone will tell you that it may stop charging in the middle of the night momentarily to preserve the battery health. And then it'll kind of finish the last little bit of charging to make sure that it's there for you in the middle of the night. So the phone is learning about when do you plug in, when do you unplug. And this is going completely unnoticed by hundreds of millions of iPhone users all around the world. We're talking about almost exactly the same thing with EVs.
But isn't that a little bit of a challenge in terms of it? I could try to do a connection here between my iPhone and my electric car. Because the iPhone, yes, I bought it from Apple, and I wouldn't say they took over my life, but literally they have all the data that they want. So leave that. But when you come to the car, suddenly now you have not only a car, but you also have this capacity in terms of battery, which means that you have at least 3 stakeholders around it. You have the owner of the car. Okay, what's in it for me? I bought the car. It's my car. It's not like just charging my iPhone. This is more than this. This is valuable. You have the utility saying, hey, I want this because I want to utilize it as much as possible. And then you have the OEMs saying, hold on, we're not just going to be a car company here or an OEM. We want to tap into this one. So kind of 2 questions around this. How do you see this? And where do you sit in this kind of triage of stakeholders?
Yeah. I think everything you just described is sort of, those are all the factors that guarantee that this is successful, right? So if you just look at V1G, so essentially changing the timing of when your car charges, that really costs nobody any sacrifice, right? And in particular, if you've designed it so that the user has a really straightforward user experience. You come home, if your battery is at 15%, you plug in, your car's just going to charge because you need the charge, right? But if you're plugging in and you're at 50%, 60%, your car's going to tell you, hey, I'm going to delay the charging until the greenest time to charge this overnight. And you'll have a button on the dashboard or in the app for the phone that says, no, I need you to just charge now. And as long as the user has that override capability, everyone is going to be completely fine with this. For enabling that service, though, there's still value that is being delivered by, typically there's some telematics that are involved in how do you get a signal from the utility to EnergyHub to the auto manufacturer down to the car. For enabling that, there's a revenue opportunity for the auto manufacturer. And we've seen lots of announcements from auto manufacturers recently about their aspirations to have multi-billion-dollar services business, software businesses. This is right in the middle of that. I won't put a number on it, but most people think V2G is going to be substantially more lucrative in terms of grid value that's delivered and how much can be captured by kind of the customer and the auto manufacturer. So yes, you're using the battery more, right? If you come home and the first thing your car does is actually to discharge, right? You're going to offset your home's contribution to the utilities system peak, or it's going to make sure that you bridge between solar and wind or whatever. There's a ton there that is using the battery more, but if there's a bunch of revenue coming everyone's way, I think people are happy to incur that, additional sort of quote unquote wear and tear. Where do we come in? So we're an invisible player in this. We're the utilities kind of signaling and intelligence layer. So we're the layer that looks at the forecast for renewable generation and says, all right, I have to get 100,000 vehicles charged. When am I going to do that? And we're the ones who say, all right, let's charge this group of cars starting at 10 p.m. and then this next group of cars starting at 10:30 and so on. So, we are in the mix, but we're not trying to steal anyone else's opportunity.
So would you consider yourself an AI company, or what? I mean, based on what you're saying, you seem like you're doing a lot of predictive. You're taking large data sets of some from somewhere, from what I'm hearing you say, and then you're doing something actionable with it. So is that more describe what you guys are?
Yeah, I think AI is a huge piece
Buzzword?
of it in trying. Yeah, that was the next thing I was going to say. I as a company, as a culture, we're a little anti buzzword and anti hype. So yes, you do need good AI to figure out, okay, how do I resolve multiple overlapping challenges? So if you're looking at a piece of the grid and you say, all right, overall the system is fine, there's no acute stress on the entire system, but we have a piece of the distribution system that is particularly stressed. You might have one set of kind of what we would call grid services objectives that applies at the local level that conflicts with another set of objectives at the system level. That could go all the way down to like the individual service transformer. You might have, the end of a cul-de-sac in the suburbs that has 4 Teslas plugged in, but the service transformer can actually only handle charging 2 at a time. And so if you think about at a small layer, how do I figure out which of those 4 cars charges first and then which charges next? And then start growing that kind of concentric circles growing around it, you end up needing to apply a lot of AI. Having said all that, some of the basics here of just following a set point of saying, I've got this much carbon intensity, or I've got these market prices, those pieces are comparably less sophisticated, or they need fewer buzzwords applied to them.
Awesome. And then I guess you've already got 1 million devices or 1 million signed up. Maybe you can give us, okay, about 1 million. Could you give me an example or a case study of something that's gone well? I think we talked in the pre-call, you gave it, but I think our users love to hear a success story.
Yeah, so I will say that, one other piece of this that hasn't come up is you kind of need a diversity of different types of DERs. Each of these DERs has sort of different physics, different kind of use cases, right? Like most electric vehicles are probably not plugged in and charging at 4:00 in the afternoon if people are doing sort of standard pre-pandemic commutes, although who knows what happens later. A smart thermostat controlling air conditioning is only helpful at certain times of the day and certain times of the year. Controlling heat, the same thing. So ideally what you have is a really strong diversity of DER types, and you can kind of stitch those together into a virtual power plant that has the capability to deliver flexibility 24/7, 365. So I guess where I would point in terms of case studies is kind of Arizona as a whole. There's been a lot in the press recently about California, because California kind of has a tendency to suck up all the oxygen. But in reality, you go across the state line to Arizona, and I think there's some really interesting stuff going on. So, you look at utilities like Arizona Public Service, Salt River Project. Often they started with kind of an executive level mandate or a regulatory mandate that just says, let's try some things with customer owned resources. And they started out at the pilot level, and sort of sought out to figure out what are the problems going to be. Is this going to scale? Is it going to deliver? If you're on your 5th hot day in a row and 118 degrees, is this resource still there? And what they found was that the answer was yes, it worked, right? And so as those things succeeded, they started scaling it. They started investing in marketing. They started tinkering with customer incentives. They started offering a wider variety of DERs.
But so you use Arizona as an example, and Arizona is probably the hottest place on earth I've spent time in the summertime, where like you can't even have a car window open; it burns your arm. It's so hot, literally. So, is it a good litmus test? Because if you said your previous assumption was air conditioning causes extra capacity in their network, so is that one of the parts of the country? Because I assume you don't live in Arizona without air conditioning, or at least you don't live comfortably in Arizona without air conditioning at least half the year. Is it a fair representation of, let's say, I don't know, New York State or some other state capabilities because of the temperature there? And I don't mean to cut you off, but that's what comes to mind when you start talking about it.
It's a great question. I think I think sometimes it's good to look at the extremes to understand, sort of the fundamentals. And the short answer is it still works in Arizona, right? Like if you if you talk to people in Arizona, for one thing, they've had time of use rates for years. So customers are used to the idea of power might be more expensive for 3 hours on a hot summer afternoon than it is in the middle of the night. So people are already used to the idea of maybe I let my house go a little warmer. I run the air conditioning a little lower power during that period. So all you're asking a customer to do is occasionally, and we're talking, in the case of demand response, you're talking about like maybe 20, 30 times per year for a couple hours at a time, turning back the temperature of that thermostat by a few degrees. And overwhelmingly, customers are satisfied. What's shocking is that if you survey customers and look at the net promoter scores, the net promoter score of the people participating in a flexible demand program is higher than what they were before they joined the program, right? Is significantly higher. Like it's in the mid 40s, whereas the background NPS of that utility maybe was 10. So this is not like wearing on customers. They actually like doing this.
But I think that's a really interesting. Do you think that's because, coming back to my question previously, in terms of this engagement with the customer and trying to not just educate them, but at least inform them, that by doing it this way, they're now feeling part of it. If you do NPI scores, net promoter scores anywhere in the world, utilities and telecom are never specifically high rated.
Right.
So maybe this is a lesson learned for a lot of other ones, that engage customers to be part of it and not just telling them what to do.
Yeah, I think this is kind of the essence of customer engagement and customer enablement. And I think this is what is so much more profound than, just sort of like doing a better website or coming up with a better mobile app or something like that. It's the customer feels like they are specifically doing something real. And if you look at how, if I were to highlight APS as one of kind of our flagship customers, how they started with the most obvious problem, which is just manage peak demand. But then once their virtual power plant got to a certain size, other parts of the organization started to realize, like, oh, something really interesting is going on with this VPP. What else can we use that for? And so the market and trading folks who manage essentially Arizona's participation in the energy imbalance market started realizing, oh, I can dispatch this resource when market prices are high. And every time they do that, they save money for the entire APS service territory. And so now you start to feel like I not only kept the lights on, I lowered prices for everybody. That's the kind of thing that gets everybody's attention. It gets the community's attention. It gets users' attention. It gets the executives' attention. And that positive feedback loop is essential to making this happen at scale.
All right. So I think you're doing where I wanted to bring this together, because we're coming up towards time. Is let's take the journey together. So we had an example of Arizona. You gave us a good use case, and you basically said incrementally they started with a specific use case, and then it kind of, the Lego blocks, as you started your career with or thought about, started adding up to the other killer apps that you could build along the way, or killer application that you could use your tool for. Could you maybe paint a picture of where we are in the journey for demand response today, and where does it go? Like where, how does this, in your vision, play out?
Yeah, I think demand response is, we're in the steepest part of the growth curve here, right? Where essentially anyone who's doing this and who has a few years of experience under their belt is now seeing, climate change leading to more and more extreme weather events, and they're just saying, how can I get more of this, right? Their 50 megawatt target from 5 years ago became a 100 megawatt target, becomes a 500 megawatt target, becomes a gigawatt target just for a single utility. So I think we will need more and more demand response. I still think that demand response is it leaves a lot of value on the table. When you're running an effective mass market demand response program, what you've done is you've gotten good at interacting with connected devices, interacting with users and getting them to sign up for some degree of flexibility, and figuring out kind of new operational principles within the utility. None of those things have to change to go from peak load management to 24/7 flexibility. So I think what I was what I mentioned with Arizona, where they start to figure out new use cases, I think where this goes is more and more use cases, is somebody taking that virtual power plant and pointing at a new problem, proving that it can contribute to that problem, saying, wow, just unlocked more value and I didn't have to ask anything more of my users. Let's point it at another problem. And you just enhance that positive feedback loop.
Which sounds like an interesting part to be on, and I think this is we've had a lot of discussions about how you integrate this technology into this transformation, especially moving into smaller units or to less less small energy units. I think that was really, really interesting. I have one final question. I know we're running out of time, but I have to ask this one. A little bit of the side note. I think, if I'm not mistaken, you're the first one that we brought on to the show. Interestingly enough, Chris being there as well. There's actually from New York City, which is usually not a energy hub that we had in the past. We have the technology hubs in California. We have a lot from Houston and Texas, and obviously some parts of Europe. So how is it to be an energy startup or an energy scale-up company in New York City, and how did you end up there?
I mean, there's no master plan here. This is where I lived when I started the company, and I didn't feel like moving, and so it was as good a place as any. I do think you have you have a particular sort of awareness of infrastructure in New York that is probably helpful as you think about all the complexity. If you look at what is it about our business, though, like we're not a hard tech, clean tech company, right? We don't need a bunch of chemical engineers building new battery chemistries or something like that. We need people who are good at building software. We need people who are good at thinking about users and coming up with a compelling user experience. And before the pandemic, this was a great place to hire. I don't know if it's fair to say after the pandemic, but whatever we're in now, we now hire people everywhere, and then nobody minds coming to visit New York City to see the mothership from time to time. So it's a good place to run a business.
Well, I think the conversation's been particularly interesting. What we did do is focus quite a bit on U.S. North America. So how is this playing out? You're a software company, right? So borders mean very little to you as long as you have the nuance of the market and the energy markets. How do you plan to take this globally, or are you already global with this?
No, we are really just in North America right now. It's a good question. So the thing that has been a surprising advantage for us in the U.S. is regulated monopoly utilities are actually quite good at delivering value with DERs in a way that so far we really haven't seen in a lot of deregulated markets. If you look at the examples in the US, Texas has like a quote unquote business friendly environment. There's not a lot of friction to doing kind of virtual power plant stuff in markets, but the value isn't really there. If you look at California, they've sort of deregulated and they have value, but they have tons of friction. It's really difficult to do business. And so the question when you look at a market like Northern Europe or Australia or parts of East Asia is how do you make this stuff happen? There are still some fundamental questions of who in the value chain gets to capture the value. A regulated utility in the US has the unique ability to capture system value, distribution value, generation value, user engagement, all of those things, and kind of bundle it into a single value stream or a single combination of value streams that can enable the business case. It's much more complex to do that in a fully deregulated market. And so TBD on how well this works internationally. I'm excited to try it. I'm particularly excited to try it with things like EVs, but time will tell.
All right. So one last question. So if our audience has been engaged, they think this is something they want to be a part of, whether they're a utility or a user at the end, what can they do to start taking advantage of these things that you just told us about?
So I would say two things. If you're a user, make sure any major purchase you're making, whether it's a car or a system in your house, make sure you're buying energy efficient DERs, right? Make sure the products are network connected and that one day you can turn them into an asset for the grid. So that means, if you're replacing a water heater, make sure you're putting in a heat pump water heater that has an internet connection. If you're putting in a new HVAC system, make sure there's a smart thermostat attached to it. If you're on the grid side, I'd say the most important thing is don't reinvent the wheel. There are so many companies doing this at scale in different combinations of geography and housing type and business types and system constraints in the US. Someone has tried this. Go copy what they're doing. One of the most interesting things about this industry is that people share information way more than they do in other aspects of the private sector. And so if one of our guests today is listening to this and wants to learn more, you can talk to me. You can also talk to my customers. I'm happy to put you in touch. So copy what worked for them and then tailor it for your particular scenario.
Thank you, Seth, so much for being our guest on the show. It's been a pleasure to have you on board. The conversation's been fascinating. Johan, if you have any final thoughts here to wrap up the show?
No, nothing further to add. I think it was extremely interesting. I know quite a lot more now about the topics. I thought it was interesting, and I got so many additional thoughts around what's going to happen. This brings me back to my IoT story when we talked about the 15 billion devices connected. We're way past that now, and energy is going to be one of the leading parts. So I really think this was interesting, and I appreciate you coming on, Seth.
I really enjoyed it. You guys do a great job on the podcast, so thanks for the opportunity.
And thank you. For our audience, you've spent another hour listening to Insider's Guide to Energy. We hope you've enjoyed the content as much as we have. If you have, please share the content, like it, subscribe, and recommend the show to your friends, because that's how we continue to grow. We'll see you again next week. Bye-bye.